Welcome to a new Voltlog. Today we are taking a look at my electronics mailbag items and it's episode number 100. So I would like to take the time to thank you guys for your support. Every view, like and share I get from you motivates me to continue producing these videos. Our first items are these two EL wire kits. This one is blue and comes with a power supply that's supposed to work with 12 volts DC input, while the second one is green and comes with a 3 volt power supply powered from two AA batteries. I was thinking I could make myself a small sign with the Voltlog logo made out of EL wire. I don't have good creative or artistic skills, but I wanted to give it a try. So let's try to power these on and see how they look. I have connected the 12 volt power supply to the blue one and I have installed two batteries inside this the power supply of the green one. So this is turned on and now I've turned on the power supply for the blue one and they look kind of dim, not what I expected. These might look okay in the dark. In fact, let me just turn off the lights, some of the lights in here, so you can see them better. Yeah, they kind of start to shine in the dark. The green one is definitely brighter, but yeah, not what I expected. And both of them produce this high-pitched sound coming from the power supply box. I'm not sure if the microphone is picking this up. Also, they don't appear to be shining from all sides. Like they seem to be producing light mainly from one side. And maybe that shines through the other half of the circumference of the tube. This is especially visible on the blue one. Like if you look at it from a certain angle you don't see any light shining through. But I paid like $3 or $4 a piece, so I guess I was expecting too much. Surely there must be better EL wire out there, but I think I need to pay more to get the better one. That's difficult to do on eBay or AliExpress because you never know how it's going to look in real life, even if you pay more for that particular purchase. But this green one might still be okay for me to give a try that logo project. And also on this controller with the AA batteries, you also get some different modes. Like right now it's blinking, now it's fast blinking, yeah, and that's it. There are three modes, so full on, slow blinking and fast blinking. While on this 12 volt power supply you just get the on phase. My next item is a Bluetooth amplifier module, and you've seen me use something similar in my Bluetooth amplifier build video. A link to that will appear on screen right now. This one is a different module. First, it's more compact, measuring just 60 by 45 millimeters, and it's using the CSR8635 Bluetooth 4.1 chipset, which should give it a higher audio quality and better experience overall when compared to cheaper Bluetooth modules. And lastly, it's using a PAM8610 10 watt stereo amplifier, which makes this whole module targeted at smaller Bluetooth speakers. So I know I've been saying I want to build a portable Bluetooth speaker for a while, but I was missing some parts and tools which I figured out recently, and now it should be coming soon, so stay subscribed. I also got another standalone CSR8635 Bluetooth module. The listing where I ordered from showed the blue PCB, but I got this green one. It doesn't bother me at all. It's the 8635 chipset that I wanted. Since I made that DIY Bluetooth audio receiver, and if you haven't seen that video, I will be posting a link on screen right now. I've been thinking I should design a professional PCB and integrate all the features nicely, make it compact, and choose an enclosure and publish the project so anyone could build their own high quality Bluetooth audio receiver for just a few dollars. So I got another one of these modules to use it in the design validation phase. It was under $4 with free shipping, and links will be provided in the description below. My next item is a preamp module based on the NE5532 dual op-amp. This is a common part used for preamp circuits. In fact, we've even seen it on the Bluetooth board. It's used between the Bluetooth module and the actual amplifier as a preamp. And I think it's somewhat low noise, but most importantly inexpensive, so you will find it in all the inexpensive audio modules coming from China. A friend of mine has this vinyl retro player, and it needs a preamp circuit before connecting it to an amplifier. So I decided to help him by ordering and installing this module. Not sure where to power it from, but I think I'm gonna have to use a small 12 volt transformer, maybe also a linear regulator with proper filtering, so to make sure I'm not inducing any noise. This module is quite cheap on eBay. It's just $3.50 with free shipping, and the op-amp is socketed, so you can change that for a higher spec part if you would want that. My next item is this programmable remote control key fob. I was quite surprised when I saw this thing on Banggood. So apparently you can use this key to learn and store settings from up to 2 other remote control fobs working on the 433 MHz frequency. For example, you could learn the code from your garage door key and use this one to open your garage door and maybe some other thing around your house. I'm thinking it should also work with other 433 MHz remotes, like the simple ones from the cheap LED dimmers or the cheap remote control, the relay modules from eBay. But that would have to be checked. I'm not entirely sure. The procedure for cloning a remote control signal is described on the Banggood product page, and it involves several steps. I might even say too many steps. I don't think it will work on more advanced remotes like the ones from your car, and that's a good thing because you don't want anyone easily cloning that. The cost is under $4 with free shipping, and it looks pretty nice. It will certainly be useful in some project later on. And let's see what kind of battery does it use. Wow, it's really difficult to open this remote. It's very well built, and I think it also has an O-ring. So just like the high quality key fobs. It just has some very strong clips holding it together. Or maybe I'm doing it wrong, but no, it's the correct way to opening it. So yeah, you see it even has an O-ring. But it's not just an O-ring, it's a complete seal on the side of the buttons. So it also acts as an O-ring on the side, so this thing will definitely survive dust and water. Yeah, you see the buttons are molded, and you also get this this O-ring that makes a perfect seal with the bottom of the case. I don't think we're going to see any numbers on that chip. They're probably rubbed off. Yeah. But the part number is TXD006 433.92 megahertz. Is that the frequency is working on? So we even get a battery inside. So it uses a CR2016 battery. Oh no, two batteries for a total of 6 volts. As you saw, it was using real tactile switches, so the feedback is quite nice from these buttons. They are a bit recessed, but they give really nice feedback, and this must be one of the best, in terms of quality, one of the best key fobs I've seen come out of China, at least in this price range. My next item is a 2S lithium battery protection and charging module. I got two of these from two different sellers because the first one didn't show up for a long time, so I ordered another one from a different seller. I think these were recommended by a viewer in the comment section, but I'm sorry, I don't remember his name right now. These are nice modules because you can truly use these to also charge your Lithium 2S pack. They don't just contain the protection IC, but they also have a step-down DC to DC converter on board. I'm not sure about the charging current. I couldn't find that mentioned in the description page, so it might be up to you to limit that externally. The board is capable of continuous output at 3 amps, and the protection will kick in at 6 amps. So you can have short pulses of up to 6 amps. The input voltage needs to be between 9 and 20 volts, so it should be safe to connect this to a solar panel to keep your batteries topped up. I'm probably going to be using this one in a project, so you will be seeing it again. The cost is around $6 with free shipping, so slightly more expensive than the just the plain protection modules. But like I said, this has extra functionality with that built-in DC to DC converter. A link will be in the description below. Next two items are related to the WeMos board that I showed in a previous in the mail. Like I mentioned, back when I ordered that board, I also ordered a bunch of these tiny shields that go over the WeMos board, and some of them arrived later than the others. This one is a battery shield which will allow you to connect a lithium cell. It has circuitry for charging the cell and for boosting the voltage up to 5 volts. And the other one is a micro SD card shield that will allow you to easily connect a micro SD card for doing some data logging, for example. Links for both of these will be placed in the description below the video. My next item is a very simple and cheap device, but it can make your life easier in certain situations. A while ago I showed this CH341 programmer that I got from eBay. It's been a useful tool in my lab. Since then I have programmed a few EEPROMs using this gadget, but the problem is I'm dealing with SMD EEPROMs, mostly in this package, SO8 package. So usually I have to desolder the chip from the board, solder it onto a small DIP adapter PCB, and then plug it into the socket of the programmer. This is where this device comes in handy. On one end you have this 8-pin clip that aligns perfectly with the pins of an SO8 package, and on the other end you have this DIP style header that you connect to the programmer socket. This is what I'm talking about. Here is the SO8 package grabbed by this clip, and those tiny gold contacts, each of those makes contact with a pin on the SO8 package. In some cases you might even get away with just hooking this up to the IC without even desoldering from the board. You just read or program it in system. In other cases, onboard circuitry might prevent you from accessing the memory, so you will still need to desolder the chip from the board, but even then it should save some time by not having to solder the chip to another board. So this is that kind of tool that everyone should have, and I highly recommend you get yourself one of these if you're in this business. My next item is probably the most iconic board that you can get these days. I mean, who doesn't recognize this board? It's an Arduino Uno clone, and it doesn't even need any description. I paid something like under $6 with free shipping for this board, and you can't go wrong with something like this. You will always need another one for some project, or you can always keep one as a spare because sometimes shit happens and the magic smoke escapes from a project you are working on and you don't want to be waiting days or weeks, in my case, to get a new board. I had different styles of Arduino boards, but I never had one that looks like the original with the white seal screen on the back. So that's the reason I went for this model. This one is a clone, I'm sure, so what I'm going to say next doesn't apply, but there is an interesting story behind the original board and how they are manufacturing it. They are not using white seal screen on the back, but a second layer of white solder mask. That is because you can get higher quality, higher resolution in the solder mask. So they come up with that method to manufacture these boards just to get a higher quality artwork on their boards. A really nice idea. My next item is an Arduino CNC type kit, and it's composed of one Arduino clone board, 4 stepper motor driver modules. These are based on the A4988, and the custom shield board for connecting everything together. I'm not planning on building a CNC machine anytime soon, but one day, just out of curiosity, I was reading on the subject or watching YouTube videos, and it appears most DIY projects are using this kit because it's low cost and there is already lots of software and examples supporting this configuration. So I figured maybe someday I will try to build something that will involve at least driving a couple of stepper motors, so this kit should come in handy. It was fairly inexpensive, around $13, shipping included for all of these, so not a bad deal for like a stepper motor driver kit. My next item is an L298N driver module. The L298N is an integrated circuit which features a built-in H-bridge designed for driving inductive loads like solenoids and motors. It's especially useful for driving a DC motor with forward and reverse functionality. On the drive section, it works with the 5 to 35 volts DC with up to 2 amps. And on the control section, it takes 5 volt signals. I think these diodes are for back EMF protection, so you don't need to add those externally. You also get a small heatsink, and you can drive a wide range of motors, solenoids with this module. It was really cheap, under $3, shipping included. I was missing something like this in my lab when I wanted to experiment with some DC modules. I think I mentioned this back in a video. I was planning like an automatic curtain closing opening system. So I figured instead of implementing a discrete H-bridge, it's easier to just get one of these modules for $3 and it does the job. And our last item for today is this very tiny sensor board. Let me get it out of the anti-static protection bag. This is the INA226 current sense module. The INA226 is quite a versatile chip made by Texas Instruments. It can do low and high side bidirectional measurements of current, voltage and power while presenting the results over an I2C interface, and all this with excellent accuracy. There are other similar chips made by TI, some with analog output instead of digital, and you might go for those depending on your application. If you're working on some analog circuitry, a power supply where you would want the feedback to be analog voltage type, then you would go for one of those sensors instead of this digital one. But this one seems to be very nice, and you can use this for pretty much anything. Building your own power supply front panel meter, measuring the power going through your DC motor or through your adjustable DC load, measuring the power consumption of your DIY gadget, insert anything here. Just endless possibilities, and it's as simple as connecting it to your Arduino. So this is also a product I recommend, and you should keep one of these in your toolbox. I'm pretty sure this will come in handy someday. As usual, links for all the items shown in this video will be in the description below, so check them out. I get a small commission from every purchase made from those links. This is the main source of income for this channel. This won't affect you in any way. The commission comes out of the seller's pocket, not yours. If you enjoyed the video, don't forget to hit the like button, and I will see you next time.